Hey guys, very welcome to my YouTube channel. This video is going to be a continuation of my previous video which I have created on segment routing. If you have not watched that video, I would encourage you to go and check out that video that has the basic configuration about the segment routing. In this video, I'll take the discussion forward with the segment routing traffic engineering, or SRTE, what we call it. In case of segment routing, this traffic engineering happens a little differently. Here we'll have to create policies, and it has become very easy to deploy now. So we are going to see that how exactly we can do segment routing traffic engineering. I have a GNS3 topology where I have SRTE policies configured between iOS-XE, iOS-XR routers. I'll show you the configurations and verification on a working setup as well. But before that, a very quick introduction of segment routing. Alright, so SRTE is nothing but source routing. Now, what do we mean by source routing? Source routing means the sender of the traffic. For example, node A is sending traffic to node D or F. So the node A would embed the complete path to reach from A to node D or node F or whatever it is. So at the source itself, we would know the complete routing path, and that is what the source routing means. So here you are seeing a picture. I would try to explain source routing a little better with this particular example. This example I found over the internet. I was going through some of the videos, and then I found that one of the Juniper engineer, Ron Bonica, he was explaining about the source routing, and he basically explained about a kindergarten kid who needs to go to his home. He doesn't know the complete path, and at every intersection of the road we have a guard who can help the kid, but the guard doesn't have any route information, any path information. So this kid has to carry the path information with him. So in order to do that, we'll put a cap on kid's head, and that cap would carry some labels, and those labels would tell the direction where the guard needs to send the kid for the onward journey. So for example, the kid starts and he reaches to intersection point A. Here the guard looks into the label which he needs to use to identify the direction where he needs to send the kid. He'll read the label and he'll pop that label out, and then he'll send the kid to intersection point number 2. Now on the intersection point number 2, the guard again reads the label and he pops out the label and send the kid to the home. Similarly, in case of segment routing traffic engineering also, the node which is sending the packet, it will put all the labels on top of the packet for the complete path, and the node which is receiving that particular packet would read the top label and try to identify the node which is advertising that particular label. Once it identifies that node which has advertised this top label, it will send the packet to that particular node after removing the top label. So that is how the communication works, and that is how the packet reaches to the destination in segment routing traffic engineering. Now with this, I'll move to my lab topology where I have configured SRTE with the help of explicit and dynamic path. I'll show you how it works. I'll show you how to configure it, and we'll see a quick demo as well. Okay, so this is my GNS3 topology. I am running it in client server mode. So as you can see that I have R1XE, R2XE, and then R3XR, R5XE. So I just wanted to tell you that these XE devices, these are all CSR 1000V devices. One of them I have opened it here. You can see that this is CSR 1000V devices, and they are running 17.3.2 release. And about the XR devices, let me just log into one of them. These are running 7.1.1, and they are XRV devices, as you can see here. So let me just quickly explain that what do I have in this topology. I am going to configure SRTE tunnel between R1 R4 and R5. So in this area of the topology from R1 to R5, I already have segment routing configured, and the IGP which is running here is ISIS. So on top of ISIS, I have segment routing, which is running fine. If you want to see that part of the configuration, you will have to watch my previous video. The link is there in this in the description section of this video. In this video, I am going to focus on SRTE between R1, R4 and R1, R5. At the bottom, you can also see the PC configured. So this device is already configured, but I have shut it down now because about PC, I'm going to discuss in my upcoming videos. The PC is nothing but a controller kind of a node in segment routing. So what it does is it sees the whole network and it computes the path. You don't need to configure any explicit path or any dynamic option on on the segment route SRTE running nodes if you have PC involved, because PC would give you the path to reach from anywhere to anywhere in the network. So we'll discuss about that in upcoming videos. For this one, I'll focus on manual configuration on SRTE. So looking at the topology again, between R1 and R5, I have a dynamic path option configured, and between R1 to R4, I have an explicit path configuration. So first of all, let's log into R1 and see what are the configuration which is needed in order to form traffic engineering tunnel over the segment routing. So this is my R1-XE router. You can see that over the gig 1 interface, I have ISIS point-to-point configured. It is configured for ISIS lab process. On top of that, if you want to see ISIS configuration, you can ignore these TI-LFA configuration for now. I'll make a separate video for that. So under ISIS, you just need to have the segment routing mpls, and also you need to if you are going to configure dynamic option under the segment routing traffic engineering tunnel, then you will have to have distribute link state, because that would enable ISIS to send the TLV options in the ISIS updates. So this command is required. The metric style should be wide, because in narrow metric you cannot send extended TLVs. And on top of that, you will also have to have this mpls traffic engineering enabled globally as well, and on the interface level as well, and also under the ISIS. So until here, all the configurations are looking exactly same as we were doing the traffic engineering with the help of mpls. Now what is different here, I'll show you what exactly is different. So if you remember, when we were doing traffic engineering over normal mpls data plane, then we had to configure tunnels after that, right? Tunnels like interface tunnel like this, and also these tunnels are shut down for now, so I'm not going to use that. Here also you can go ahead and configure tunnel, and you need to specify the tunnel type as segment routing and all that. But that is kind of a legacy method to do it. I'm not going to use this tunnel, although these tunnels are also segment routing traffic engineering tunnels which are configured manually. But as you can see that I have shut them down. I am not going to use it. I'm going to use the segment routing traffic engineering policy here. So let's move to the policy configuration for now. I'll explain the policy configuration that would make things a little more clearer for you. So for that, I'll go to segment routing configuration. If you see the segment routing mpls configuration, there is nothing special here. I have associated with one of the loopback which has the IP address 1111, and the index I have given is 1. I have not specified any particular segment routing global block, so it will take the default block and it will add the index value. So you can guess that the node ID, which is also mentioned here, in this case is 16,001, which 16,000 is the base value of segment routing global block, and it has added one on top of it. So this is all. This is normal segment routing configuration, which prepares the data plane. Now on top of this segment routing, I have configured segment routing policies. You can see this is the complete policy configuration. At the bottom, you may see the PCC configuration. As the PCC is shut down now, that is not relevant, and also I don't have any policy configured for PCC, so you can just ignore this part of the configuration. You can focus this particular part of the configuration. Here you can see that under the segment routing traffic engineering section, I have specified a segment list basically, and what the segment list is consisting is the node IDs. So it has the node ID 16,002, 16,004, which is R2 and R4. You can also specify IP addresses here, next hop IP addresses or prefix its, etc. Now let's see the policies that I have configured. So I have two policies. Looking at the policy, you can understand that one policy is going to 5555 and another policy is going to 4444. So 555 is my R5 router and 444 is my R4 XR router. So let's concentrate on policy 2 first. It is the explicit path policy, and you can see I have specified a color here first. This color is giving a unique identity to these policies, and then we'll have to configure the candidate paths. So I just have one candidate here. The preference for that candidate is 100, and this configuration is saying that I'm going to specify the path explicitly under the policy. So what is that path? That path I have already configured earlier. SR path policy 1 and SR path policy 1 is the explicit path. So you can just ignore this policy 1 part because this is just the name, although it is named for policy 1, but I am calling it under the policy 2. So that name is irrelevant. You can configure anything as per your convenient. But looking at the configuration, you now understand that from R1 to R4, I have an explicit path which is going from R2 to R4 directly. And if you want to see the configuration on IOS-XR router, let me just log into this device. I'll quickly show you the configuration here also. So command to check the segment routing configuration is show run segment routing. Here you need to concentrate on the policy 1. So you can see that policy 1 is configured for 111 router, which is nothing but my R1 router here. And here under policy 1, I have two explicit paths. One explicit path is as you can see that SR path 1 R1 is the name. So SR path 1 R1 is going to R2 first, and then it is going to R1. And the other path which I have, SR path 2 R1, it is going to R5, then R3, then R2, and then it is eventually reaching to R1 router. Between these two paths, I have given some weight which is necessary if you want to load share between the paths. I'll show you how basically this load sharing is working at the end of the video. But for now, I just want to see if these policies which are configured on R1 and R4 are working fine or not. So in order to do that, I have loopbacks created. So till here what we have IGP. On top of IGP, I have segment routing configured, and on top of segment routing, I have my SRTE policies configured. So how do I ensure that those SRTE policies are working? So on R1 and on R4, I have some loopbacks. For example, here I have loopback 2, loopback 3, and loopback 4 configured, which I am going to use to check for the connectivity. And also on R4 router, I have some loopbacks configured, which I'm going, so you can see that loopback 2 and loopback 3 is configured here. So these two loopbacks I'm going to use in order to test the connectivity. So from here, from router R4, I would try to ping those loopbacks. Those loopbacks are not advertised anywhere. You can see the configuration here. Show run interface loopback 2. You can see it is not under ISIS. So what I have done is I have configured static routes pointing to the policies that I have configured under the segment routing. So if I scroll a little, you can see these three routes that I have configured. This 20.2, which is the loopback configured on R4 router, 20.2 is the loopback 2, and 20.3 is the loopback 3 on R4 router. So these two routes I have specified where the route type is segment routing, and it is using policy 2 to get out of the router 1. And similarly on R4 router also, if you do show run static show run router static, you can see that I have static route configured for 192.168.10.2 and 10.3, which are the loopbacks here, 10.2 and 10.3. So in both the routers I have the static routes configured, which are using the these policies, SRTE policies, to have the reachability. So let me see if first of all if we are able to ping it or not. If you want to ping this 20.2, which is on XR router, sure enough the ping is working fine here. So I'll move to R4 and I'll just trace 192.168.10.2 10.2 first. Alright, so it is going to router 3, router 2 and router 1. Since router 5 is directly connected, you won't see the label for it. So in order to reach 192.168.10.2, which is the loopback 3 configured on R1XE, it is taking the longer path. This is because I have done the load sharing. So it is going towards R5 first, then R3 and R2 and R1. This basically explains that we are taking the segment routing specified path. And let me just quickly show you that which path it is taking. So we'll go to segment routing configuration, and you see that this particular path it is taking. This is the longer path. All right, so this explicit path is working fine. Now let me just move to the dynamic path configuration. On router R1XE, you can see that if we go again to segment routing configuration, I have one policy which is configured for the dynamic path in this case. On XE router, you don't have an option to configure IGP metric for dynamic path. There is just one metric which is constraint based. That means mpls TE based metric you can configure. First of all, by looking into the policy, you understand that it is configured for 5555 node, which is the R5 router here. And the candidate path is of type dynamic, preference is 100, and I'm using constraint based SPF, which is MPLS traffic engineering based SPF. So this is the configuration what you're going to need in order to configure dynamic path on Cisco IOS-XE router. So let's see at the other end what configuration do I have. I'll log into R5XE router. Let me just show you the alright segment routing configuration here also. Here you can clearly see that the configuration is exactly same, just the node ID is different. This is 1111 and the path option is dynamic here also. So let me show you if it is working or not. Okay, now coming back to R1XE. So in order to verify if the policies are up or not, the command is very simple. Show segment routing traffic engineering policy all. If you know the name of the policy, you can also specify the name of the policy. Like I have POL1. Sorry, you need to specify name first and then POL1. You can see that this particular policy is administratively up and also operationally up. And if you see policy 2, which is configured for XR router, here you can actually verify that it is up operationally and administratively also. Now coming back to R5XE also, if you want to verify traffic engineering policy, the command can be policy all, because there is just one policy. I'll just do policy all. You can see this policy is already up. It has found its neighbor, that is 1111, and it has come up. Now it should be usable right now, but how I am going to verify the connectivity is with the help of loopbacks again. So I have loopback 2 configured here, and on router 1 you already know that we have loopback 1 2 3 2 3 4 configured basically. So here on router 5 also I have let me show you what route I have. You can see that to reach to 192.168.10.1, which is the loopback configured on R1 for the loopback 2. I am going to use segment routing type of route, and the policy which is going to be helpful here is policy 1. If I ping 192.168.10.1, you can see that ping is working. If you have any doubt in your mind that if it is using this route only or not, you can actually do few commands like show IP route 192.168.10.1. so this is the static route which I am using here. So there is no other route available, just one route which is configured statically is being used here. So let me just quickly verify the connectivity from this end also. You can see that loopback 2 is configured on R5, so I'll verify the connectivity of loopback 2 from R1 also. So if I do ping, it should work. Show IP route for this. You can see that it is also pointing towards static route. So with this, I have the segment routing traffic engineering configured between R1, R4 and R5. And all of them are working fine. Between R1 and R5, I have explicit path configured. And between R1 and R5, I have dynamic path option configured. This all is working good. This all is working as per the expectation. Now, one more thing is left. Let me just show you the configuration of dynamic policy on XR router also, because you may need to configure it as a dynamic option. Till now, I have only showed you explicit path on iOS-XR router. Although dynamic option is configured on XE but not on XR. So configuration is exactly same. There is not much, but still it is good to see. So this is another policy which I have configured between R4 and R5, which is configured as a dynamic option. And here you can see that dynamic metric type is specified as mpls TE. So here you have the option to configure this metric type as IGP. This is all it is needed. And if you want to verify if this particular configuration is working or not, the command is show segment routing traffic engineering policy, and the policy name you can specify. I think name is POL2. So you can see this policy is up. I can use this policy, but other end I have not configured anything. On R5 there is no policy configured towards R4, so it is not going to work just now. I'll have to do some more configuration on R5 in order to make it work. So anyways, but you can see the policy is up this side. So one side of the tunnel is up. You know that traffic engineering tunnels are unidirectional. So other end also I need to configure a tunnel. So as soon as that tunnel comes up, this should be fine. But anyways, till here the agenda is very clear. I just wanted to show you the configuration of dynamic policy. Now moving to my last part of the demo, I wanted to show you that how exactly the load sharing is working in this case. So you remember the part of the configuration. Let me just scroll down and show you. Yeah. So under this policy is going to 111 router. I have two explicit paths, and I would like to show you that how exactly the load sharing is working here. So I have this segment routing explicit path. One path is going via R5, and another path is going directly to R2 and R1. Although I have the shortest path available in the network, but I'm still going to use all the path which I have, just to load share, just not to overwhelm any of the particular link what I have in segment in my network. So I don't want to overwhelm the link which is going to R2 and R1 because I have an alternate path, and it just has two extra hops, so I think it should not add more delays. So I'm going to use that. Okay, load sharing what I have configured is 4:6 and 2:6. You can understand that 2/3 of the traffic will go here and 1/3 will go here. So let me just recall how I was testing the connectivity between R1 and R4. I had two loopbacks on R1 which I am pinging from R4. Those loopbacks are loopback 3 and loopback 4 on the R1 is configured. Now let's trace and try to identify if both of them are taking the same route or not. So I'll just trace route. You can see when I am tracing 10.2, it is taking the longer path that we have seen earlier also. Now if I trace 3, let's see if it is taking the same path or not. It was very difficult to identify the weight which will serve this purpose, but thankfully I was able to do it. And if you do trace this 10.3 IP address, you can see that although both of these flows are going to the same router, but both of these flows are using two different paths. So this is how I achieved load sharing in my SRTE network, and this is very easy to do, not much of the configuration needed. And this is also one of the feature which comes with SRTE, and as long as the feature is easily deployable, I think more and more people are going to use it. So this was very exciting. I really had fun making this video. I hope you would enjoy the video, and please help the channel grow by liking, sharing and subscribing. Thank you so much for your time. Have a nice day and happy learning. If you have any question about this particular topology, you can put the question in the comment section. I would try my best to answer it. And if you have any question about the topology, that how I am building it, how I am maintaining it, you can also ask me over the comment section or anywhere you find me. Thanks so much again for watching. I'll see you in my next video of segment routing. Till then, happy learning.